Hello everyone, I'm Sally. Welcome to my video. In this video, I'm going to be asking you a question, another interview question. If you remember the first one over here, we've been improving it, and this is the time for the second one. So I'm going to be asking you a question, and also I'm going to be showing you 3 different ways that you can achieve, or you can succeed, by the way. But also every iteration, so every answer is going to be better than the previous one. So the version 1, version 2, version 3, again, actually this is the same what we've done in the previous video. If you haven't seen it, please watch it first. In this video, imagine that you are in an interview. It is easy sort of question, by the way. Imagine you are in an interview and you're asked to find a solution for this question. So it says, in Linux, commands are essential for interacting with the system. We have common commands like ls, cp, and mv, so list, copy, and move. There are also special commands that starts with exclamation mark. For instance, if exclamation mark 2 is the command, so it re-executes the second command in the history. So this is the command line or command index, I would say. If the history commands points to a command that we don't have in the history, then we should be ignored. It should be ignored. For example, it says 20, but if you don't have any 20 item in your history, then it should be ignored. Your task is to write a C# function that takes an array of string that representing a sequence of commands. These commands will only consist of ls, cp, move, and this is guaranteed. Or a history command that starts with exclamation mark. The function should analyze the sequence and return an array containing the total count of each command ls, cp, and move within this order. For instance, this is the command set you are given. It says cp, cp, ls, m1. So every time it executes one command, you need to increase a number. So in this line, for example, we increased cp. It's because cp is executed, right? So in this line, cp1, and then again cp2, and then ls1, and then move1. So far 2, 1, 1, right? So this line says, okay, go to the third command and re-execute it. So 1, 2, 3. The third command is ls, so we need to re-execute this one. So far it was 1, and I'm going to increase it to make it 2. So it says go to fifth. So 1, 2, 3, 4, 5, and then this says go 3. So 3 is ls again. So it is going to be 3, right? So and then the fourth, and this is also going to increase the cp again. So this will be this was 1, 2, and this is going to be 3. So the result will be ls, cp, and move, which 4, 3, 1. So this is your job. I'm going to be showing you 3 different ways. So analyze command v0, v1, v3, or 1, 2, 3, it doesn't matter. But there will be 3 functions, and we will be returning, we will be printing out the result just to see if they all work the same way. So the 0 is going to be the worst approach within this project, I would say. So what you would do, you would create a dictionary with counter 0, right? So then you could access it in constant time to increase the value. This makes a lot of sense though. And then you could create a for loop that you loop through all the commands within this and create another function. So why do I create another function here? The answer to that question is recursiveness. It's because it says, for example, go to 5, but 5 is this one actually. So I need to go 3 again. So it is basically a recursive function that calls itself until it reaches something that doesn't start with exclamation mark to be able to execute that one. So that's why I had to create a function that calls itself depending on the situation. So in that one, actually, all lines, all the commands are sent to that function, and that function also accepts an index, so it knows that what command of that index will be executed. And it says, okay, give me the command. It checks the command, and I have internal function over here, but it doesn't have to be. It checks the command if it started with exclamation mark. If not, basically increase the number. So the number is basically whatever we have in this dictionary with this command, and it's increasing the number. So that would be over here actually the same, no matter. And you could get rid of this. But if it starts with exclamation mark, then what I need to do is to parse that value, right? So I need to parse. I need to get rid of this, and I need to have the value. So if it is 5, for example, if it is 3, for example, I need to get that 3, which I'm doing over here. So I'm using the substring function of that command, and also getting the value, try parse, if you see. If I'm able to parse, I need to check something as well. If it is greater than 0, right? It's because it says go to the third line. So 1, 2, 3. If it was 0, I don't have any 0 item in my command list. So the first one should be 1 according to the question. So that's why it needs to be greater than 0. But also it needs to be less than what I am on right now. So this line, for example, 1, 2, 3, 4, 5, in 5th index, right? So I shouldn't be able to write 30 over here. In my history, whatever command I'm putting now happened before me. If it says 30 or like 7, I shouldn't be able to execute that one because I don't know what's going to come after this one. So I need to do another check over here that says, okay, this line, so this number should be before me. And this is where it is actually. So before index. That's because index and we have +1, it should be equal. But yeah, get the number first and check if it is greater than 0 or equal and less than the index, the commands, the current commands index, right? If so, send the -1. It's because this will be 4, but you need to make it 3 because of the index thing. But this works perfectly. This is going to be fixing it's because it is now calling itself the same function recursively. It's not going to be stuck on that one. If it is 5, it will be finding this 3 and then the go ls and increase the number. So this is going to work perfect. And afterward, so after I'm done with this recursiveness over here, I have my dictionary. I basically select the value, the number, and to array. So this is the first approach. It seems perfect, but it is not. Why it is not? So the first thing is that we are creating memory allocation over here first, right? So we've got 3 different values in that dictionary. So this creates memory allocation. And another memory allocation we are creating is exactly over here. So this is a string. If I use a substring, which means I'm creating another string over another string. This could be improved. I will show you in a minute. So this is the second place that I am creating a memory allocation. And this is the third. So I already have my dictionary and I am now calling toArray function, which creates additional array. And this is the third place in that function that I'm creating memory allocation. But this is what we don't like. So even though this is going to produce the right result, the correct result, but this is going to be slower than the others. So let's examine the others. So let's switch to V1. In V1, instead of having a dictionary that holds my value, what I'm doing is I create an array already and return that one. I don't need to create something else over that. It's because I have the value. I have the array already over here. So again, actually, use the same approach, have a function. It's because it is going to be calling itself recursively. Now, as I'm not using a dictionary, I need to check this deliberately. And I have a switch function, switch pattern over here. And it uses span, if you see. So imagine I say, okay, get me the number, get me the command, and also get me as it is span. So I can pass read-only span over here. So try parse also accepts read-only span. I don't have to pass a string over here. As I'm still using this span, I'm not creating additional memory allocation over here. So this was the first place that I avoid creating. I mean the dictionary. And this is the second place. So now I'm avoiding creating additional memory allocation over here. The rest is same, and this is same. And this is, this is going to be checking if it is ls or cp or move, and then get the index, and then increase the value by that index. And also this function is going, so there is no another memory allocation or accessing the dictionary, as I don't have the dictionary already. So as I'm now using span, I needed to do something like that. But the good thing is that I can use span with switch pattern, which is perfect. So this is the better approach. So you might think that, okay, what else can I do? So I already avoid creating additional array. I have only one, so I have to create this one. I'm going to return this. And also I'm using span, so I'm avoiding creating another memory allocation over here. It seems to be perfect. Yes, it is almost perfect, but we still have a better approach. So the third one, so V2, says almost the same thing. So this is going to be more readable. For example, in over here, Rider also warns me, says, okay, the internal functions should be moved after return to be able to make it more readable, I can say. And also having a return after that one. It is, if so, this is calling itself every time it comes over here. It needs to check if it has the same function defined already or not. So to be able to avoid that one, so it needs to be moved after return. This was the first command, so I moved everything after return. This is the same. And the other thing that I've done is instead of having a recursive function, I create a loop. And manipulate the data in that, so I can break and I can continue and everything. What does this differently if I say, okay, split right? So this is going to be the first approach, and this is going to be the second one. So instead of having a recursive function over here that calls itself, I'm now having a while loop, so I can break and continue sometime. So the advantage of while loop over here that has over having a recursive over here is that so every time you call a function, its reference goes to stack in the memory. It goes stack. And then when you call again, it goes stack again, and then again, and then again. And once it is done executing that line, it removes it from the stack. So every time you call a function, you need to store the data at the point of it is being called into a stack, and after it is done, you gotta remove it. In that case, I am creating a few stack data. We know stack is so performant, so fast, so we can just insert something over there, add something there, and then remove it. It should be super perfect. It should be super fast. Yes, you're right. It is going to be the fast, but also slightly slower than having only one while loop and run it. So if you have while loop over there or a recursive function, it is going to be slightly faster than the original one, and the one that we've been using this recursiveness. But in memory wise, in allocation wise, it is going to be the same. It's because I haven't changed anything. It is the while loop already, and it is the recursive already. The rest is the same. Let me run this function first, and we see the results for 3 of those here. So you see 431 for all the functions, return 431. So now I'm going to go back to benchmarks, and basically I copied and paste everything over there. And I am now creating 3 functions with the same parameters I had. So I have the same comment set. I have the same functions 1, 2, and 0. And I'm going to be benchmarking this. So let me make sure it is released, and now I run that. The result will be here in a minute, and you will be seeing something different. All right, we have the results. So it just took a minute or so. So the results are over here, and you can see the first approach, V01, has the worst memory allocation, right? 464 bytes, and as well as the worst as in time, 207 nanoseconds. And as I just said, this is going to slightly faster, but in memory wise, those 1 and 2 will be same. It's because, yeah, there's no additional memory allocation improvement on the second one. But as I just said again, this is going to be slightly faster just because not using this stack every time for this, because of this recursiveness over there. So these 3 approaches is showing you how you can handle those sort of questions. So array manipulation, data manipulation, string manipulation, and memory allocation, especially memory allocation, so time complexity and space complexity are super important for that questions for that interviews, especially if you're a junior. It is even more important than the everything else in that interview. And to be able to manage the memory or memory allocation, you need to be practicing a lot. So if you watch my videos, I will be showing you a couple of ways where you can improve yourself in. So this was the second question, but there will be even more questions within this interview video series. But also imagine you are asked within this question. So I will be giving you homework, right? So this is your homework. If you are asked to detect if there is any loop. So what I mean, so it says go to 5, right? So 1, 2, 3, 4, 5. What if this says go 6? So this says go 5, but I mean, actually it cannot go, it cannot say 6. It's because it will be ignored if it says. But imagine you are given the whole list. It is not the history, so you shouldn't ignore afterward. If you are asked to detect again, let's say it's 6, so this needs to go 5, and this needs to go 6, and this needs to go 5, and this needs to go 6 again. So there's a loop over here, the cycling. What if you are asked to detect this situation as well? So what would you do? What sort of feature that you would add within these functions? And to be able to use less memory and to be able to more performant, what sort of approaches you would have? Just let me know within this comment section below. And also, if you like this content, please hit the like button, subscribe, and if you want to be notified for the other videos like that, please make sure that you hit that notification bell. Until next time, happy coding!